our next figure is figure 6.6. These are analyzing series parallel circuits with random unknowns. And again, random unknowns means I'm not just going to have the resistors and the total voltage. I'm going to have a miscellaneous. So it's going to be like a puzzle. And each one of these four I'm going to do is going to be like a puzzle. So the first one, figure 6.6. Here we go. It's got 3 resistors and 2 branches. 1 resistor here, and then 2 resistors on the back branch. Voltage total equal to, let's see what information they gave us. They give us voltage total, they do. They call it 90 volts. So I know I got 90 volts total on the battery. I know R1 is 30 ohms. I know R2 is 20 ohms and R3 is 25 ohms. So that doesn't look like random unknowns really. So this won't be very much different. R2 is 20 ohms, R3 is 25. R3 equals 25 ohms. Again, we're going to solve this using the resistances, the same thing. First thing I want to do is combine my series. So I'm going to make a simplified circuit with 2 branch resistors. So we still got voltage total equal to 90 volts. R1 branch is 30 ohms. We have to simplify R2, 3. Again, these two are in series. So R2, 3 is going to equal R2 plus R3. And again, that's 20 ohms plus 25 ohms. So R2, 3 is going to equal 45 ohms. Now, we could solve for our total here, doing product over a sum. We could go 30 times 45 divided by 30 plus 45. But they want to do it a different way here. They want to solve using the branch current. And one thing we know about parallel circuits, if you remember your parallel circuit in your last course, we know the total voltage in parallel because it's equal to this, right? There's one loop, here's the other loop. You got 90 volts on both resistors. So VR1 is 90 volts, VR2, 3 is 90 volts, and so we can solve for the currents here. So IR1 equals VR1 over R1. In this case, it's 90 volts divided by 30 ohms. So IR1 is equal to 3 amps. And IR23 is equal to VR23 over R23. And that's 90 volts divided by 45 ohms. And that's 2 amps. And current in parallel is the sum, basically because of the nodal equation. I don't know what I total is, but I know my current in the first branch is 3 amps, and I know my current in the second branch is 2 amps, which means my I total would have to be the sum of those, because I have to have 5 amps coming in to have 3 amps and 2 amps going out, right? So I total equals 5 amps. And I can solve R total this way now. So this is like a different way of solving it from the current point of view in a parallel circuit. R total equals V total over I total, which is 90 volts divided by 5 amps. Okay, so I get my calculator, 90 volts divided by 5 amps, and I get R total equal to 18 ohms. Right? So now, so my I total up here is 5 amps, and my R total is equal to 18 ohms. We've already solved everything on this one, right? Because we know VR1 equals 90 volts, and I know IR1 is equal to 3 amps. But we haven't solved these yet, but we do know the current going through them. The current is 2 amps. So IR2, because the current going through R23 was 2 amps, and that's series, which means current's the same, so I got 2 amps there, I got IR3 equals 2 amps there, so VR2 is equal to I times R, which is 2 times 20, which is 40 volts, and VR3 is I times R, which is 2 times 25, which is 50 volts, and 90 volts in a loop, minus 40 volts, minus 50 volts is 0. And so we have solved everything on that figure. Again, a little differently. You could have solved for R total if you wanted to, but they wanted to show you if you got 2 branches, you can solve it with the currents, because voltage is the same in parallel.